Welcome back to the Scotti-BYTE channel, and this is Scott. So sometimes self-hosting really means combining together a set of tools that are available to you in your home lab in order to solve a particular problem. And that's what we're going to do today. So with that in mind, I've entitled today's presentation, Self-Hosted Camera Magic. So the mission we have is to display a 4K H.265 encoded IP camera in its full resolution of 3840 by 2160 using an Amazon Echo voice command. So the problem with this is that an Amazon Echo Show 10 has a resolution of 1280 by 800, but fortunately it's capable of rescaling to higher resolutions with a similar aspect ratio. And cameras with a 4K resolution are encoded with H.265 instead of H.264. So H.265 is a great codec, and it gets over double the compression rate of H.264, but not without some shortcomings. So all wired IP cameras, all wired IP cameras I've been able to find have a 10100 NIC installed in them instead of a gigabit interface, and that's what requires H.265 compression for any 4K video source. So Amazon only supports displaying cameras that use H.264 and not H.265. And even the Fire TV 4K and the Fire TV 4K Ultra sticks are limited to displaying 2K cameras which use H.264 and have resolutions of 2560 by 1920. Those of you who have used cameras in conjunction with Amazon Echo devices know that Amazon Lexa has skills. And I primarily use Reolink and Amcrest cameras, and they both have Lexa skills that you can enable for those brands of cameras as well as many others. Many times the camera skills are more suited to smaller displays like the Amazon Echoes because they often use the RTSP substream and not the full resolution primary RTSP stream offered by higher resolution cameras. So an example is my 4K Reolink RLC-820A, and it has a primary RTS stream resolution of 3840 by 2160, but my Reolink skill uses the substream to display that camera at 640 by 360. So I really don't want to see my 4K camera displayed at 640 by 360 on my Samsung 65-inch 4K TV. I'd really like to see the full 4K resolution that camera is capable of. So the irony is that the Fire TV 4K Ultra that I have and the Samsung TV can both easily display 3840 by 2160 resolution. The limitation is that Amazon cannot work with the H.265 encoded cameras on their devices, and the camera skills and the ability to show cameras are all limited to H.264 encoding. So to bypass the actual resolution issue, I use the monocle portal skill at this URL here, which allows most cameras with RTSP streams to run through a small local service that you host on your network called the Monocle Gateway, and it provides the proper encryption and security between Amazon devices and your IP cameras that you have locally. And that's even if that IP camera does not have an Amazon skill associated with it. So I use the Monocle Gateway to display my 2K Reolink RLC-520A cameras, which, by the way, are some of my favorite models for outside security cameras. And they display in their full resolution of 2560 by 1920, but that's only because I'm using the monocle gateway to display them, and also because they're H.264 encoded video streams that are compatible with Amazon. So sadly, the monocle gateway cannot deal with H.265 encoded cameras, and that's not really a limitation of the monocle gateway. That's a limitation of Amazon's ability to deliver camera streams, because they only work with camera streams that are H.264 and not H.265. So here's a diagram describing how I displayed a 4K 3840 by 2160 H.265 camera on my 4K TV in full resolution with a voice command. So I basically have an IoT network. That's what this horizontal line is here, and it's addressed at 192.168.30, and that particular network is what I refer to as my IoT network. And for security reasons, I put things like my security cameras, my Amazon Echoes, TVs, and Chromecasts and such, Fire TVs, all those things on that IoT network. But my main network, I have other things, and one of the things that I have, we're going to talk about in here, is I have a Habitat Elevation C7 hub, and that's what I use to handle the voice part of this connection. Well, actually not the voice part, but the code that enables the voice part of it. So starting down here, I have an Amazon Echo in my family room. It's actually truly an old style Echo, and it listens for the command Lexa, show me the mailbox, and it turns on a momentary virtual switch over in the Habitat, which is named Display Mailbox on TV. So this goes out to Amazon, and it runs a routine, and that routine listens for that phrase, and once it hears that phrase, it turns on that switch. When it turns on that switch, I have an Amazon Echo skill for the Habitat, which links the Amazon to my Habitat, and then it goes ahead and invokes that skill to turn that switch Display Mailbox on TV on the Habitat Elevation Hub. Then I have a rule machine, which is one of the apps that you have on Habitat, that sends a post command to this particular IP address, and it invokes a routine that we're going to talk about shortly whenever that virtual switch turns on. And when that happens, it goes ahead and issues that post command, which accesses the server down here. So if you watch my channel frequently, you know that I always talk about LexD containers because they're highly efficient. This could be a LexD container. This could be a Raspberry Pi. This could be a virtual machine. But for our purposes, I'm going to describe this as a LexD container. So this LexD container has Python and also the VLC program installed. So a lot of people are familiar with VLC. You think it's a video player, and that's true that it is, but it's also something that is capable of taking an input stream from another location, like this camera here, and it's taking its full H.265 encoded video stream that is at 3840 by 2160, and then it's providing it back to this server running VLC. The server running VLC is relaying that connection out to my Chromecast 4K Ultra, which is also connected to my Samsung TV. And basically, the two pieces of software installed on this small LexD instance are Python and VLC, and probably this app altogether takes less than certainly less than a gig of memory, probably more like 700 or 800 megabytes of memory to run the Ubuntu LXD instance. So then it goes ahead and the Samsung TV sees the input coming in from the VLC server after initiating the voice command. And then what it does is it sees activity on the HDMI port where the Chromecast Ultra is connected, and it uses HDMI CEC to switch the input on the Samsung TV to that of the Chromecast. Now, I took this kind of a step further in my environment, and this has been around for a long time over here, but I have a Logitech Harmony Hub, and it tracks which activity, like for example, maybe watch Fire TV is engaged, and therefore it knows which HDMI port that's running on. And so when HDMI CEC switches ports from whatever I was watching, whether it's the TV, a Roku, the Fire TV, or whatever, it'll give me a point of reference to return to the original input. So I have a web core routine in Habitat, and it's tied back to a routine again. And I basically say, Alexa return, and it switches back from the Chromecast Ultra to whatever I was watching before I initiated the camera command. So we're going to go off and take a look at how this is implemented. So here we are in front of a 65-inch 4K Samsung TV running the Fire Stick 4K Ultra. And I'm going to use the voice command to display one of my standard cameras, which happens to be a Reolink 5 RLC 520A camera. Okay. The goal of this project will be to display a full 4K video resolution of a Reolink 820A camera. And so the command I have here is, Alexa, show me the mailbox. So here we are on one of my LXD hosts, and I'm going to create a LXD container for our VLC transcoding server. And the command I'm using is lexc launch ubuntu :2204. I'm naming the container VLC. I'm including the default profile as well as the IoT profile. So in previous videos, I pointed out that I have an IoT dedicated network, and I created an IoT profile that will give this container an external address on that main or that IoT VLAN. And it's important that you not create the container without presenting it out to either your main LAN or VLAN, because otherwise it'll get a NAT address, and that won't work for what we're doing because of the bidirectional communication that's going to be required over a number of ports. And then I have limits.memory is 2048 megabytes or 2 gigabytes, which is probably more than enough memory. In fact, over twice as much as I need. And I say that back on the LXD host, you can use up to 10% of the CPU. And boot.autostart is set to true. And what that does is it just goes ahead, and when the LXD host reboots, it goes ahead and starts back up also. So now that the container has been created, it's just that simple. We can do a lexc exec VLC and go into the Bash shell, and that will give us a root prompt off on that particular machine. Well, whenever you create any new instance, it's always important to do an apt, and we're not having to do the sudo command simply because we are root, but it's always important to do an apt update, and I'll say ampersand apt upgrade, and that'll go ahead and bring this particular instance up to the latest version of the repository and install any updates that have occurred recently. Now that my machine is updated, I always like to create myself a local user account, so we're going to do an add user on Scott. Give Scott a new password. And then I usually like to grant myself sudo privilege also, so I'm going to do an apt, or not apt, but a user mod, -a, capital G, sudo Scott, putting Scott into the sudo group. And then I'm going to do a snap install on VLC, because VLC is going to be needed to be able to transcode our camera. So now that we have VLC installed, we also want to install Python, and we're going to do that with a sudo apt-get install python 3-pip. So we go ahead and say yes, and it goes off and performs the install for Python. Now that VLC and Python are installed, we're going to go ahead and add a unprivileged user called VLC, and that name VLC will become important later because some other code is going to rely upon it. So I'm going to do an add user VLC. I'm going to give VLC a password. I'm not going to give VLC any privilege because this VLC account is going to run a web application, and it's generally very dangerous to have any of your web applications run with privilege. So I'm going to SU over to VLC right now, which will make me the VLC user. And then I'm going to do a pip3 install Flask. So Flask is a lightweight development environment for Python for web applications. And once we do this, we have our virtual environment ready in order to install our application that's going to run VLC. Next, we're going to create our Python script, and we're going to do that with nano VLC _ control.py. And this is the Python script. We'll be including the source code in the show notes, so I encourage you to refer to them. So there's nothing really special about this except for the fact that it hosts the VLC command that will actually be running to do what we want to do. So let me go through this. Well, actually, let me go through this after I save this out because it'll be a little easier to see. The thing I want you to notice about the script is all the way at the bottom, it has port number equal to 8080. So by default, you would think that you'd run web pages on port 80 or port 443, and that's true, but it's also important to note that if your port number is below 1024, that is considered to be a reserved port, and development ports are only from port 1024 and above, or above 1024. So in reality, what happens is that if you're running below 1024, the application is going to have to run with privilege in order to be able to bring up the web server properly. So let's dive a little bit deeper by catting the script out to the screen. And the important part of this is going to be the VLC command. So here you can see that this thing invokes a VLC command. The first parameter I have here, --run-time 60, says that this thing will run for as long as 60 seconds, and then after that, it will exit the VLC command, which is ideal. We don't want this thing to run forever because if your Chromecast disconnects, it'll just be hung up here at the host. And then --intf dummy, what that does is it redirects all of the standard screen output log information and just sends it to a dummy file because it's not needed, and we really don't have any terminal associated with this thing once it runs as a service. Now the real meat of it here is your RTSP command for your camera. So RTSP is real-time streaming protocol. The first parameter there I have is the username on the camera, then a colon, and then the password for your camera, followed by an @sign, and then the TCP/IP address for that camera, which is in my case 192.168.30.60. That is my Reolink RLC 820A H.265 encoded camera. And then most of the times RTSP streams are offered on port 554, and that's what I've got here, port 554. And then they usually have a web route at the end of them that talks to the camera and says where to get the RTSP stream from. In the case of the Reolink camera, that is this particular Reolink camera, it's /H265 preview underbar 01 underbar main, and that means it's getting the mainstream as opposed to the low resolution substream. Then what we have here is an sout command, and it's going to talk to the Chromecast, which is at yet a different address, and the Chromecast IP is 192.168.30.109, and that's where it wants to stream the RTSP coming from the camera to. And that's basically how this VLC command operates. The next step that we want to do is we want to do a chmod +X to give the script executable privilege. So it's a chmod +X VLC underbar control.py. And then we want to be able to set the privilege on this file. And we're going to do that with a chmod 755 VLC underbar control.py. At this point, we can check our web server out interactively by simply doing a Python 3 space VLC underbar control.py, and it warns you that when you do it interactively, it comes up as a development server, not to use it in production. And basically, it's sitting here waiting for the connection at 192.168.30.145 port 8080. So an ordinary web browser issues an HTTP GET request and not an HTTP POST request. So in order to get a POST request, I went ahead and popped up another terminal, and this terminal is on my local machine here. And you can see that it is issuing an HTTP-JSON POST in capital letters, HTTP : the address port 8080, just like it says up here, and then /VLC, which is the endpoint for my script that gets executed. Now, in order to run the HTTP command, you're going to have to do a sudo snap install HTTP if it tells you it's unavailable. So let's go ahead and hit enter on this command and see what happens. You can see over here, you get this no such file or directory. That's normal. And now it's accessing the system. It's launching VLC out there, and it's waiting for the connection. And it has now displayed on the remote system, so it has shown the mailbox camera over there. So now that the camera is displayed on the Chromecast, to go ahead and exit the test, I can just do a Control-C over here. It goes ahead and interrupts that. I can exit this terminal. And to turn off the server, I can do a Control-C a couple of times, and we're back over here. So our next step is to figure out how to automate this process. In order to automate the running of our VLC script, we're going to create a system service out of it, and we're going to exit the unprivileged VLC account, and we're going to sign on to the privileged Scott account, which I granted the sudo privilege earlier. So now I'm going to do a sudo nano /systemd /system/VLC underbar control.service. And I previously made the entries over here, and you can see that it's called the VLC control service. The username is going to be VLC, so it's going to run under that unprivileged VLC account. And then it's going to use Python 3, and it's going to execute this Python script that's located over on the VLC account that we just created and ran manually. Restart equals always means it goes ahead and restarts if the service stops for any reason. And then you, by standard, you need this wanted by equals multi-user.target command as a part of the service. So we do a Control X and we save that file out. To turn this into a service, we simply do a sudo systemctl enable VLC control. And then to start the service, we do a sudo systemctl start VLC _ control. Now, the enable command means that every time the system boots, we want the service to start, and the start command that we just used now starts the service. To see that the service is running, we can do a sudo systemctl status on VLC _ control, and you can see here that the service is up and running right now. The VLC server is now sitting out there and listening for an HTTP post request to the address of the server. And so I went in and defined a Habitat rules machine rule, and I named the rule show mailbox camera on family room Chromecast. And then I select the trigger events, which is when display mailbox on TV, which is currently off, turns on. Then it goes ahead and runs the action, and the action is to send a post command to http://192.168.30.145 port 8080, and then the endpoint is VLC. And as you'll recall, when we send a post command to that endpoint, that initiates the VLC script. The VLC script runs to attach to the camera RTSP stream and reoffers it on the Chromecast. When it sees the data coming in on the Chromecast on the TV, it goes ahead and uses HDMI CEC to change over to the Chromecast input and then display the camera on the screen. On Alexa mobile app running on my phone, I went ahead and defined a routine called Show Me the Mailbox, and whenever Alexa hears me say, Show me the mailbox, it goes ahead and turns on a virtual switch called Display Mailbox on TV, which is a momentary switch that I have created over on Habitat, and Habitat rule machine is listening for this switch to turn on in order to execute the HTTP post command to launch VLC. So in summary, the Video LAN client, which is the acronym for VLC, can not only be used to play a video source, but it can stream a video source to another device, as we saw in this tutorial. And we also used VLC to access a 4K Reolink RLC 820A camera with an H.265 encoded stream at a resolution of 3840 by 2160, and we displayed it on a Chromecast Ultra device connected to a Samsung 4K TV. So an Amazon Echo routine listened for Show Me the Mailbox, and then it turned on a switch named Display Mailbox on TV, which triggered a Habitat skill to send an HTTP post command to a LXD server instance running VLC as a service. An HDMI CEC control on the Samsung TV automatically switched inputs to the Chromecast Ultra device to display the camera. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.